Good evening. Welcome to our first public meeting in the town of Merrimack for the Beals Road Bridge project. My name is Brian DeFosis, and I'm the town engineer from the town of Bedford. Here together with me are Don Tuamala from the town of Merrimack, who's the DPW director, as well as Brian Patinskis to my right, your left, and Samuel White to my left, your right, from McFarland Johnson, who are the project engineers. We also do have together with us tonight a representative from the Merrimack Town Council, Finlay Rothaus, and residents and abutters to the project. This project is now 11 years in the making, going back to 2013. Project aims to replace the existing bridge with a precast concrete arch bridge over Babusick Brook. The existing bridge was built in 1928 and last modified in 1984. The bridge number is 105/055, and it's registered with the state of New Hampshire. The approximate average daily traffic over the bridge is 680 cars per day as of 2021. The bridge is a concrete slab structure. It's 23 feet wide, 23 feet long. State bridge inspectors rate bridges based on a numeric system, with the number 9 being new and under 4 being called poor, also known as red listed. The last inspection was in July 2022. The deck and superstructure were rated good, a value of 7. The substructure is rated poor, a value of 4. Conceptually, the proposed bridge will be 36 feet wide and 36 feet long, a full 13 feet wider in each direction. It will extend further upstream or to the west in the direction of Parkhurst Road. It will be approximately the same location on the downstream side of the bridge. It will move a little towards the Bedford side of the alignment by about 5 feet. This meeting is intended to gather information, hear concerns from the public, and consider any questions before plans are more fully developed and finalized. We have a short PowerPoint presentation that will show where we are currently with regard to the project. This will also show the detour route we are anticipating. After that, we will have time to open the floor to public comments and questions. While this is the second meeting, where there was a meeting in Bedford last night, I would encourage the public to make similar comments or the same comments that they did previously so that they're on the record in both towns. We may not have answers to all of your questions at our meeting tonight, but we will be evaluating the comments and questions in the coming weeks. Once the design is completed, we will be conducting a follow-up meeting on March 27th at 6 p.m. at 10 Meeting House Road in Bedford to show the final design of the project and discuss any questions. As indicated earlier, if you do have questions, please use the microphones. And with that, I'll turn it over to Brian Patinskis from McFarland Johnson.
Thanks, Brian. So tonight we're going to go over this presentation, as Brian was mentioning. So as part of it, we're going to go over the project location, why we're replacing the bridge, the project limits, the design considerations, the construction schedule, as well as traffic control, the estimate and where the funding is coming from, and then we'll take your questions at the end. So the project location is located in the southwest corner of Bedford, or northwest corner of Merrimack. It's on Beals Road in Bedford, and it's Woodward Road in Merrimack over the town line. And also in the area is Parkhurst Road, and Babusick Brook is running through the center there, as you can see. Sam's going to talk about the bridge now.
So why replace the bridge? As Brian mentioned, the bridge was constructed in 1928, rehabilitated in 1984. The 1984 rehabilitation focused on the superstructure, which is why its condition is rated higher, 7 out of 9. And just to build on the rating system that inspectors use for bridges, it's part of the National Bridge Inspection Standards. It evaluates 3 major components of the bridge: the deck, superstructure, and substructure. As Brian mentioned, the superstructures, both the deck and the superstructure, are condition state 7, meaning good. The substructure is rated a 4, and to land on the municipal red list for the state of New Hampshire, you need one of those major components to land in a 4. So the substructure being a 4 or poor puts it on the red list. And part of why it's rated 4 are the inspectors noted separation and settlement on the foundations. The existing structure has a concrete abutment placed on top of stone masonry, and there's voids starting to show below those. That's what some of these pictures are showing here. The upper left, you kind of see that void coming underneath the corner, or the separation coming under the corner of the abutment. And then the upper picture on your right shows some of the separation in the wing walls. So the project limits, because of the funding, it's funded through the state aid bridge program. Everything related to the project, it must be tied back to the bridge to be eligible for that funding. So that would be tree clearing, paving, guardrail, drainage, the loam and seed. Those efforts are associated with replacing the bridge. So elements that are affected on the road, like pavement replacement, tying back in, all that work is just, again, to replace the bridge. And actually, to back up there a minute. So the red line on the graphic is the rough project limits around the bridge. So on the downstream side, keeping it a little bit tighter to the bridge because the topography on the upstream side goes a little bit wider. And then along Beals Road and Woodward Road is tying back in that pavement that's affected due to the bridge replacement. So design considerations, similar to just about any bridge project we look at. These are kind of the main high level ones when we look at bridge span and replacement alternatives. First, we really prefer that long term, the most durable structure we can get in there at the most effective cost. So the graphic on your right here would be is what we're looking at, a buried structure. So you see a lot of concrete there. The concrete wall over top the structure is a head wall that retains earth. There's a couple slides after this that will illustrate that a little bit better. And then the walls running along the bridge are wing walls that retain the earth on approach. Hydraulic capacity, there's a lot of larger storms that have been around, so resiliency is important when we're looking at a structure. The new structure will be designed for the 50-year storm with 1 foot of freeboard. So that freeboard is measured from the water surface elevation to the low point on the bridge. And that additional space is intended to allow debris to pass during high water events and not clog the opening. As it pertains to the permitting and just the overall fit with the stream, wildlife connectivity is an important facet of designing a new bridge span. So providing dry passage through the bridge for terrestrial wildlife, that's part of it. And stream crossing compatibility, that's looking at stream metrics. So our environmental folks went out and did a stream assessment of the bridge or the area, and the span was developed, again, considering economy and accommodating the stream based off those metrics. So this graphic here shows the bridge kind of blown up for what we're proposing. This would be the proposed structure replacing. So we're looking at a 36-foot span, which Brian mentioned at the start of the meeting, with a 12-foot rise. And that 12-foot rise is measured from the bottom of the arch or the top of the footing. And the footing would be these rectangles right here. So that rise is measured from the top to the apex of the arch. That thick black line over top would be your pavement. So this section is looking along the stream. The stream's going through the bridge, and that white space between the pavement and the arch would be fill, so earth. The nice thing about these structures is it removes some of the maintenance facets that are common with bridges. So joints routinely fail on bridges, causing maintenance issues long term. Putting in a buried structure removes those. So your long-term maintenance needs look more like it's a road. So it'd be pavement repairs through the course of the structure, as opposed to having to do more hard repairs like concrete or steel repairs. I guess that's the benefit of a buried structure. And the stone you see inside of the arch That's the riprap that's used to protect the footings during a scour event. So making sure that the footings don't get undermined and scour out, causing an instability long term. So this section's intended to show the width of the bridge along the road now. So now we're moving back up top on top of the road. So these pieces right here would be your guardrail. Thri-beam is the type of rail that we're using over the bridge. This piece right here would be your head wall. So that would be the piece that you're seeing right there over top of the arch. And then these segments are the arch itself. So they come in pieces for installation about 6 feet wide, and they come in leaves, and you kind of place them side by side on top of the footing. So rail to rail, we're looking at 28-foot width. That's two 10-foot shoulders, which matches the existing condition. 10-foot travel lanes, and then 2-foot shoulders with a 2-foot gravel space to the rail from the edge of pavement. So water diversion to build the bridge, we have to maintain the stream. So these are just some schematics from other projects. Generally speaking, what would happen is they'd build a sandbag dam upstream and downstream, and then support a pipe, a temporary pipe, on top of those sandbags through the crossing, the bridge area. That would maintain the flow of the stream during construction and allows the area for the bridge to be dry. I'll kick it back to Brian.
All right, so back to the roadway design. So there's several considerations that we had to take into account when we were designing this. So there's approximately 700 vehicles per day crossing over this bridge. We're going to be designing it for 30 miles an hour. There are some utility poles that we're going to have to relocate as part of this, which I'll get into on one of the next slides. And one of the improvements we're going to make is sight distance. You can kind of see in this picture, there's that little kink in the road there. So that's just going to be one smooth straight into a curve instead of curving right and then curving back left. So it's going to be an improvement there. And then as part of this, there will be some impacts to right away at the corners of the bridge to grade out stuff and do water diversion. And then there's also some drainage structures we got to put in to replace what's there. So here's a picture of the proposed roadway section. So this is the same dimensions as that are on the bridge. So we're doing a 10-foot painted lane and then a 2-foot paved shoulder. And then there's also a 2-foot gravel shoulder on the side of that. So same dimensions as the bridge. And then as I mentioned, there are some utility lines that are going to have to be moved. So that yellow line there on the screen, those are the existing lines. So the pole that's located at the intersection of Woodward and Pinehurst, that one definitely needs to be moved. And there's possibly one more on the Bedford side that'll have to get moved. But we'll know that as we get further into design. And then here's a picture of the guardrail that we're going to install. So that's a standard end section that you see on the top there. And then the bottom picture is the Thri-beam that Sam was talking about earlier. So that's a picture of Jenkins Road in Bedford. So it's a very similar structure and similar setup with the guardrail. So if you wanted to see something that's similar to this, you can go take a ride over there. And
yeah. So construction schedule and traffic control. To build the bridge, we need to close the road temporarily. So the old bridge needs to be ripped out, new one put in. Generally speaking, we're looking at about a 4-month closure in the location of the bridge for that to occur. There may be traffic impacts before and after that closure, and so lane reductions. That would be potentially to do utility relocations. So instead of doing that during the roadway closure, we could condense that by doing that ahead of time, keeping the road active. And there may be some slope work after the bridge is complete and reopened to traffic that may need some space up on the road. So there might be a lane reduction for that too. Total construction duration, roughly 6 months is what we're looking at. That would be from when they get out there and start to when the contractor is more or less departing the site at that point. And in terms of advertisement, we're looking late this summer for advertising the project, and construction is anticipated to begin in the early spring of 2025. Brian? Oh, I didn't know you put it in front of me.
All right, we just wanted to talk about the detour a little bit too. So the bridge is obviously going to be closed during construction. So to get from the south side of the bridge to the north side of the bridge, we're going to provide a sign layout to take you down Parkhurst to Babusick Lake Road, and then that'll take you to Route 101, and then you'll take Gage Girls Road in Bedford, and then you get back to Beals Road from there. And that's approximately a 9-minute detour, or 4.7 miles. And then we've also heard that a lot of the Merrimack residents use this road to get to the transfer station. So we're also going to provide a sign package to get there from the south side of the bridge. So from the south side, you'll take Woodward Road and then take Bean Road and then take that to Bedford Road. And then you can get on Lawrence Road and finally get back to the transfer station. And this is approximately 11 minutes and 4.7 miles to get there. And then lastly, for the estimate and funding, so the total project cost, including design fees, is approximately $1.9 million at this point. The town of Bedford and the town of Merrimack are responsible for 20% of that. So 80% is going to be paid by the state. And then same for the right-of-way, 80% comes from the state aid bridge, and then 20% is for the towns. And 17% is Bedford and 3% is Merrimack. And then once we get to construction, it's going to be 100% federally funded through the new mobile program. And the full acronym is the Municipally Owned Bipartisan Infrastructure Law. And with that, we'll open it up to any questions you may have.
So if you have questions, if you could approach the microphone and say your name and your address, if you could, please.
Hi, Alyssa Price, 61 Parkhurst Road. My question I have is regarding the detour that goes out to 101 for Gage Girls Road. Will there be any traffic assistance provided? Cars taking a left from Gage Girls onto Route 101 face a pretty challenging and blind curve left turn. So that could make for some challenging conditions.
Hi, Finley Rothaus, 14 Kid Lane. I was just wondering, in '84 when the bridge was constructed, did the town participate? Did Merrimack participate in that construction? And then second question is, how do we come up with the 17% of the 20 combined? I was just curious of that.
Both good questions. So let me just address the previous question first. Gage Girls Road, looking left. I'll make sure that those sight lines are clear. We don't have a signal there currently. You could actually travel further to the next intersection if you felt uncomfortable taking a left on Gage Girls Road, but I could say from the town of Bedford's perspective, I will make sure that the sight lines are as clear as possible so that you have as much time as possible. Finlay, in regard to your question, it's an excellent question. I did not discover in any of my research as to what happened in 1984. I did have some older pictures, but that's about all that I found. Regarding the 17 and 3% split, I will try to explain best I can. This is currently a proposal between us. The towns of Bedford and Merrimack have not made a formal agreement at this time. But as things currently stand, based on the actual plan view square footage of the bridge, it's something on the order of 6.5% is in Merrimack, and the remainder is in Bedford. If you look at the footings of the structure, the calculation's a little bit different because the footings actually come out further. And if you do that calculation, it ends up being something like 9.2% in Merrimack and 90.8% in Bedford. There's another difficulty in that there's an abutment in Merrimack, and there's 3 abutments in Bedford. And the abutment is that long wall that comes away from that bridge. And so trying to figure out a percentage based on an abutment, one of three, is not necessarily a straightforward calculation. And so what I have presented to Dawn for consideration is that instead of trying to figure that out based on a some other method, that we use it as a percentage, and we take that 9.2% and we inflate it to 15%. So effectively, we're saying 15% would be Merrimack's share, 85% would be Bedford's share. If you take 20% of 15%, you get the number 3% exactly. And if you take 20% of 85%, you get the number 17% exactly. And so effectively, it would be that Merrimack would contribute 3% of costs of determining right-of-way and engineering, and Bedford would pay 17% of those costs. Additionally, Merrimack would pay 100% of any easements that would have to be secured in Merrimack, and Bedford would pay 100% of the easements that would have to be secured in Bedford. We've estimated those costs to be something on the order of $8,500 for the town of Merrimack, and in Bedford it would be something on the order of $50,000. Everything else would basically be paid for by the state and the federal government. So it's a bit of a bargain price for a bridge as far as I'm concerned. Does that answer your question, sir? Okay. Other questions, comments from the public, or things that were not addressed at previous meetings, perhaps? Don, did you want to talk at all? You don't have to. I'm just. Okay. Thank you. Okay. Seeing none, if there's no, yes, sir.
Charles Ackerman, 229 Beals Road. And about the slide that you had where you showed the rocks coming out to protect the footings. Are they coming out into the stream to cut down the width of the stream going through? Right, but does that wall restrict the flow of the water so the water can only flow between the two sets of rocks that are there? Oh. Mm-hmm. We're not connecting in my question. If the two stone walls come out like this and have a gap between them, how wide is that gap? Is it as wide as today's bridge? Is it narrower? Or is it wider?
It looks like it's slightly narrower.
So the water flow would actually be restricted by that compared to today's bridge.
No, it wouldn't be restricted compared to today's bridge. So the overall hydraulic opening from the ground elevation to the top of the structure, that annular space inside the bridge is increasing compared to today's bridge. So if I could draw the bridge, the existing bridge on this section,
Mm-hmm.
it would look. So it would come up with a vertical line probably about there, up to the roadway surface.
Oh, I see. Okay, it's that
Yeah.
much bigger.
So yeah,
I just graphically couldn't-
wider.
But so the water flow is about the same through there at the low level, not the 50-year flood level, is
Yeah.
about the same as what it is today.
Yes.
That's what I was.
Sorry, I wasn't understanding. Yes, you're right.
Yeah, that's why I said you and I didn't connect on
Yep.
what I was asking, because I was under the impression I had 36 feet of water flow going through there, which I don't. I've got
No.
the smaller amount going through.
Correct. Yeah. So like a normal flow condition.
But as the water goes up, then because the wall slants away, it becomes a wider space for the water to go through.
Absolutely.
Okay, that's,
Yep.
yeah. I wasn't sure if that was showing something that was underground or something that was in the actual path of the stream itself.
Gotcha.
Okay. Do you want me to bring my concerns up from yesterday's meeting for this one also, or?
I think for the record, I think it's a good idea.
Okay. At the Bedford meeting, several things came up that, well, first, I walked in late, so I didn't catch all the information that I have today, but yesterday, I was asking if they're to get bedrock to put the bridge on, would there be blasting taking place in the area? And it was entered that probably not, but also when you have rocks, they don't form a nice flat tabletop like you need to put the bridge, pylons on, and the footing, so there could be some heavy-duty chiseling going on to the rock base to get it level, but there wouldn't be any pylons being driven into the ground, so we wouldn't have a hammer-type effect taking place driving the pylons down in. So those were three concerns that I had, and then the other concern that, which was those were related to the bridge and the pylons being established in the footings. The footings are going to be mostly rock that's there, and then some concrete to make them big enough for the pylons to stand on, if I understood it correctly yesterday.
I can review with this picture. I think this is blowing up a little bit better.
Yeah, no, this picture is fine for that too, because
Yeah.
the footings are on the right and the left underneath the,
Correct. Yeah, so this footing right here would be poured on top of rock if it's encountered after it's leveled out,
yeah,
or earth. So we did do a subsurface exploration with a geotech. So the earth that was found is suitable to bear a footing on. So if they find earth, the footing can bear on that. If they find the rock, they'll have to level it, as you stated. And the pilings, we wouldn't need piles because of that foundation capacity provided by the rock or the earth. There's no need to provide piles below the footing to provide support for it.
okay. And the footing just goes the full 36 foot parallel to the stream then.
Correct. So this footing.
This is an end view of it, and it would go
Yeah.
36 feet back in, so it'd be one footing for the whole width of the bridge.
Correct. This footing that's under the arch,
Yep,
and then the footing there'd be another smaller one likely below the wing wall.
oh, the come back this way.
The walls that come back to support the grade.
Yeah,
So these walls right here
right,
would have a smaller footing underneath it.
okay. Which would be the same concerns. You'd have to have the rock or the dirt and
Yep.
so that they'd be solid to balance that wall on.
Yep.
Okay. And then the last concern I had yesterday was the fact that right now, because of the narrow bridge, people have to slow down to go across it because you can't get two cars across it comfortably because of its present width. And after they get across the bridge or as they're coming to the bridge, people speed up and go very fast through that area. So I'm concerned that by straightening this out and making the bridge wider, I'm going to have a lot more people speeding through there, kids and at night and during the day and everything. But that was brought up that's a concern I got to bring up with the police to try and do something there. The bridge, itself won't be affecting that because you're building it to be 30 miles an hour going across that bridge. So that I assume is because of the width of the lane for the traffic to flow in. Is that what determines a 30-mile-an-hour bridge?
Brian, did you want to speak to that?
Yeah, 30 miles. So for the amount of traffic on this road, 30 would be the minimum we'd want to go. So we get those from ASHTO usually. So
Oh,
We-
okay. That's
we wouldn't
not,
want to go below 30 on this.
that's not, all right, that's not based on how the bridge is constructed.
No, it has nothing to do with the bridge. No.
That's just a minimum speed for going over the bridge.
Yeah, it's more of a roadway issue.
So they can go faster and be okay.
Yeah, exactly.
All right, misunderstood that from yesterday. And then are we going to, maybe not now that I understand, but I was going to say, you're going to be posting speed limit signs for the bridge there on both sides?
Because there's a town line there, typically you would post a speed limit sign for each entity. In this case, there's a nice sign there that says Merrimack speed limit 30 right next to the bridge.
Okay,
I noticed that there is no speed limit sign that I could see in Bedford, but I'll make sure I resolve that.
all right, yeah. I didn't realize there was one on Merrimack there, on their side of the bridge. Because you've got that funny intersection right now there that two people, I don't remember the names of the roads on the Merrimack side, but come together. That's pretty close to the bridge too. So,
It's right at the intersection of Parkhurst and Beals. So
okay. And from recollection, I think that's all that I brought up yesterday with my concerns was for the construction of it. And then the dead end sign, is there going to be something like that on Beals Road so people don't come off of and turn right to come down towards the bridge? Will it be up at I'm terrible with road names. Foxwoods is built there. Not Beals Road, but the one Gage Girls. No. It's not Gage Girls, but you come up Gage Girls and you took a right into Wentworth Woods. Yes. And then come down and then a Gagnon Road or something. Yeah, would they put a dead end sign so that people wouldn't be turning to come down and find the bridge out and have to turn around and go back up again?
there'll be construction signage there. Additionally, we usually put a variable message board out there ahead of time, letting people know that the traffic pattern's going to change.
Okay, but I mean, just in general, there should be something there while the construction's going on too.
Yes.
Just
I don't want to have everybody turning around in your driveway. Or,
thank you. You knew what I was going to say next. Okay, that was the other thing, was that it showed that. So thank you for your time.
You did have a concern about your large pine tree, and I looked at the area
Oh.
for the second time today.
Yes, I saw you out there today. Yeah.
Yeah. I did talk to my boss, Jeff Foote, and we're going to do a memorandum of understanding with you. And I'm highly confident that we're not going to touch that tree
Okay.
as part of the construction.
All right.
Second thing was you asked about two large boulders on the side,
Oh, yes.
potentially moving those. Mm-hmm. I'm not sure if those can be moved by the contractor. They're so large. I'm assuming that they got there somehow, but that would be a construction.
The contractor that put the drainage system in moved them
Okay.
because they were dug up when they were digging up to put the pipe in underground.
Yeah.
And I happened to spot them, and they were going to haul them away. And I said, no, keep them down there so that people don't drive into the stream, off of Beals Road there.
Right.
So, yeah, they were moved by construction equipment.
Trying to talk them into moving them up the road may be a little bit of an effort, but I will do my best.
All right.
Okay.
But that was just to keep the stream from having cars go down through it rather than going across the bridge in the wintertime, because back then that was getting pretty slippery, that part of the road, Beals Road.
That will be covered by a guardrail now.
Now,
so
yes, yeah.
Okay.
So, okay,
Thank you.
you're welcome.
Andrew Duane, 10 Dwyer Street. Quick question. Is there going to be a posted weight limit on this bridge, or is it covered by the weight limit for the roads themselves?
The new bridge it won't be posted for a weight limit. it'll comply with what the national standards are for a design vehicle, which is far larger than what would probably be able to fit down this road.
Concerned about an influx of large trucks, because right now that's a little bit of a barrier to anything too
Yeah.
large getting down there.
Yeah, the posting would come off. But I guess that would be up to the town if they want to do something.
We do have that posted as no through trucking.
Oh, okay.
That that would be an enforcement issue, but it is posted.
Ryan Price, 61 Parkhurst. Just curious about add on to the traffic problem too. Is the new bridge direction? So a lot of the traffic we have coming from Beals onto Parkhurst, again with the fast cars, you can hear screeching tires at night and even during the day too. So I was wondering if that's gonna slow down traffic at all, turning right into Parkhurst at all. Yeah, and also, is it possible when the bridge is built, because there's a lot of walkers that walk across that bridge, is it possible to have a separate lane on the other side of the guardrail that can be a walking lane?
Thank you for those questions. So, first question is a geometric question relative to Parkhurst. Did you want to handle that, Brian?
Yeah, that's something we can certainly solve. We can sharpen that radius a little bit. I know yeah, that's something we'll definitely look at.
Second question is relative to the bridge width. Did you want to speak to that, Sam?
So on what we're providing right now for the bridge, looking for that walking path, providing a wider shoulder area and that gravel spot between the white line and the rail will improve sight lines for pedestrian traffic. Providing a sidewalk would need to tie in on either side, which is difficult to do when there's no approaching sidewalk. Yeah, yeah.
So we did actually approach DOT about this matter years ago and actually got the bridge to be widened, the proposal, so that there's basically a 4-foot strip between what we call the travel way, which would be the white line, the fog line, to the front face of the guardrail. So there's a 4-foot strip on either side of the bridge that'll allow pedestrian and bicycle movements. If you go out there currently, even though there's a white line, the guardrail is pushed in on each side, so you know that people are basically riding along the. That's right. So
The existing condition has a guardrail right here. So the new one's being pushed back 4 feet to give you that wider width.
You wouldn't be able to move that guardrail in and put the walkway on the other side of it. So you have a guardrail between the walkers and the road.
Or shift the whole thing over a little bit, get rid of the 2 feet on one side and 6 feet on one side. And the guardrail over.
Put a wider path on the upstream and then narrow it on the downstream, just because it's already a dangerous side.
we're just asking if you could speak into the mic. I'm sorry. They're not picking you up in. Would you mind asking the question again, please?
Sorry, so the question was to allow for better pedestrian traffic. Instead of having that 4-foot improvement on each side from what it current state, could we provide more allowance on one side, maybe like the upstream side, because that does provide better visibility, and have less of an allowance on the downstream side? That way you could have a 3 or 4 foot wide actual walking path to allow more clearance between you and the cars versus having just a little bit on either side.
Okay, thank you. I'd have to look in to see if that was considered or if that's a possibility. But I appreciate the sentiment and the question.
That's all right. I was actually going to try to address one of your concerns, or several of your concerns. I had approached, a week ago or 2 weeks ago when we had our meeting, about changing the intersection at Parkhurst and Woodward. So there's a big radius that's there now. If we can narrow that down so we can have more of a T intersection, because there's no need to have that big radius there that, encourages the speeding going around the corner, basically, and then right up the hill. So if we were to maybe tee it a little bit better, that might address some of their safety concerns with the speeding. And I assume the town council would be willing to go along with that change. Okay.
Thank you.
Mhm.
So one of the things that was brought up at that meeting, I should just say for the record, was that DOT is replacing a bridge, and they feel like there are things incidental to that, but they don't want to redesign town roads. And so we have to effectively sell to DOT that this is a safety improvement that's part of the project. And so those are conversations that Dawn and I can have with McFarland Johnson and DOT as things move around. Thank you. Charles, did you want to speak again?
Because I didn't speak into the microphone, I wanted to make sure everybody understood what I was saying, and that is take the guardrails and move them closer in towards the roadway, and then put the walking paths on the other side of the guardrails so that the cars would go down the road, you'd have a guardrail, and then you'd have the walking path. Whereas now you have the road, the walking path, and the guardrail.
Typically, guardrails aren't used for pedestrian safety or to act as a buffer between pedestrians and traffic, because guardrails will hit and flex if they're impacted, and so the pedestrian really isn't any safer being behind the guardrail. But it's a good thought, and hand in hand with the earlier thought about changing where that pedestrian walkway location is. We can give that some more thought.
Okay, I understand, but also it would help with the speed of the cars going through there too, because the narrower road surface for the cars to drive on would be there with the guardrails in towards the center line more.
I understand the sentiment. If you look at the guardrails on the bridge currently,
Yes.
they've been bent back so much that they're actually flat, and that's probably somewhat from plows, because plows are so large.
Yes.
When you have
okay.
a plow wing, you have to basically move the plow over the double yellow line to plow. It's not the safest maneuver to do.
Mm-hmm.
So they end up rubbing those, and I'm sure there's some vehicles that have rubbed them as well. So,
Probably, yes.
guardrails work best when they're actually in a W shape and not a flat piece of steel. But
Understood.
okay.
But yeah, I'm concerned. I was just concerned that the guardrails could help people be away from cars, because going across the bridge, people going across the bridge too quickly is unsafe for the pedestrians too, even though they have the walkway, because cars don't stay within the lines all the time either.
Yep.
Okay, thanks.
Understood. Thank you. Other questions, thoughts, concerns? Okay. Seeing none, I'll close the public hearing for tonight. And again, just to reiterate, we will have a follow-up meeting on March 27th at 6 p.m. at 10 Meeting House Road in Bedford, which is called the Bedford Community Television Building, BCTV. Thank you very much. Have a good night.